So we're going to talk about writing proofs for a few minutes here, because this is a often misunderstood topic in Foundations 30. Many students can come up with an example to show that something we're asked to prove is true, but a proof is not one example. A proof means that you have shown that it is true in every possible case. Therefore, you can't use one number. It needs to be a variable to represent any number. Okay, in the back of the textbook on page 525, if you haven't noticed already, there's a glossary back there. Each unit has definitions, and you can find most of those definitions in the back of your book, which is a great place to look. So when I look up proof, it says a mathematical argument showing that a statement is valid, meaning true, in all cases, or that no counterexample exists. So these generalizations are true, and we're going to do a proof together in a little bit. These generalizations are true. Let me grab my highlighter. Number one, when it says a number, you can use the variable n, or any variable, but you need to pick a variable. When it says two consecutive numbers, this is the variables you should use, n and n plus 1. If it talks about an even number, we know that an even number can be represented by 2 times n. That way, if n is 3, you still end up with an even number. If n is 4, you end up with an even number, etc. So 2 times any variable means even. Odd, likewise, then, would be an even plus 1, 2n plus 1. When we're talking about a 2-digit number, we use the variables usually a and b, meaning digit, the tens digit and the ones digit. And a 3-digit number, likewise, is a, b, c. Okay, so let's try an example. I'm not sure of the assignment for this section in your notes, but I did look at page 31 and in your textbook, and it has several questions that ask you to prove. Here's the word prove, here's the word prove, prove, okay? These all examples are not enough to show a proof. So I don't want you to find a number that works and write it down. You need to use a variable to prove it. Now, let's do one together. When you're proving, you're going to need to use a T-chart. A T-chart is like this. On the left, you're going to have the mathematical statement, and on the right, you're going to have the reasoning, or the justification, sometimes the heading is. So let's look at number 10. We are going to prove here that whenever you square an odd integer, the result will be odd. So your first statement should always be a definition of what variables you're going to use. So we're starting with an odd integer. So let's say that 2n plus 1, and our reason is definition of odd integer. Okay, that comes from this chart that we looked at. Any odd number is going to look like this. Okay, it doesn't have to be an n, just has to be any variable there. Okay, so we have our odd integer that we're talking about. Now, the second step in our T-chart, it says proving that whenever you square an odd integer, okay, so we need to square that integer. So our second step will be 2n plus 1, that's the integer, and we square it. Let's reason, or what we're just doing. We'll just write square. I think that's good enough. We could write definition of squaring or multiplying by yourself. I think that's okay. Now let's do the work. So we have got 2n plus 1 multiplied by 2n plus 1. I'm hoping you remember how to FOIL that. FOIL standing for multiplying the firsts, multiplying the outside numbers in the binomials, multiplying the inside numbers, and then the last numbers. So I'll do that here. 2n times 2n, we have 2n squared, and 2n times 1 plus 2n, and then the insides, 1 times 2n. If you can see what this answer will be, you don't need to show this middle step, but I'm doing all the work. 1 times 1 is 1. And then we can group the like terms to be, okay? Now, the reason or the justification over here, let's say multiplying binomial, multiplication would be fine, and then, I don't know, that's pretty much what we did down there too. And now let's say grouped like terms. So you're writing down here just what you did each step. Okay, now we're supposed to prove, grab my highlighter again, we're supposed to prove that the result is odd. So we need to show in our statement section, we need to show an odd number. 2 times something plus 1 means odd. So grab my pen back here. I like this plus 1, that means odd. If we could factor out a 2 here, which it looks like we can, it would be odd. So if we factor out a 2, we're left with n squared plus 2n plus 1. Okay, so that's the definition of odd right there. We've got 2 multiplying by something plus 1. That's it, proved. So here what we did, we factored out a 2. And then when you're done a proof, when you've shown, we can just say QED, that's a Latin term. It means I have completed showing what I set out to prove. That's a loose translation of the Latin term that stands for. Okay, and how did I know it? That was the definition of odd. Okay, that's a proof. Now you can try number 11, number 12, number 13. Check in the back. They have all the answers and they have very logical proofs that you can use as an example when you're doing your unit hand-in assignment. Okay, again, this is page 31. Great. If you have any questions, please message me.